All right, let's get started. Thanks for joining us today. We're excited to introduce you to our newest robot, the Opentrons Flex, a robot that fits you and your lab. Up top, I just want to remind everyone that this webinar is being recorded and it will be made available on the Opentrons website. We'll also be sending a copy of this webinar and recording. We'll send the slides and the recording via email within 48 hours. So to help with the overall webinar experience, everyone's on mute. To ask a question, use the Q&A box in Zoom on your screen, and then we'll answer questions at the end of the talk. All right, let's get started. I am Mike Cardarelli, Director of Product here at Opentrons. I'm joined today with two of my colleagues, Scientific Director, Dr. Kinnery Watson, and Senior Product Manager, Mike Todaro. Both Kinnery and Mike have been heavily involved in the Opentrons Flex development and launch. Before we get into the details of the Opentrons Flex, I'm going to give you a little background on what we're doing here at Opentrons. This is the full company mission statement. I'm not going to read it all to you, but you can take a closer look when we export the slides afterwards. The way I think about our mission is Opentrons is trying to free up scientists to do the important and world-changing work that only they are capable of doing. I think other lab automation providers probably say they're doing something similar to this, but I think it's our approach at Opentrons that really sets us apart. So what is it that makes our approach different? I think, first of all, Opentrons is radically accessible. Our products live in some of the biggest labs in the country and some of the smaller labs that are just getting started with automation. We have designed our hardware and software to be intuitive and easy to use, decreasing the learning curve required to get up and running on our platform. Second, Opentrons is open. It's in our name. Our software, firmware, and APIs are fully open source, offering customization options and a hackability that our competitors can't match. We're also reagent and kit agnostic with hundreds of different free protocols available for download in our protocol library. And finally, Opentrons is scalable. Our platform is built to be modular. You can use whatever pipettes, modules, and labware that are needed for your workflow. And then if your needs change in the future, it's easy to swap in new pipettes, modules, or labware to update to a new workflow on the same robot. So, our part of the company at a glance, the robotics org, our presence in labs has been growing exponentially the past few years. So we now have an install base of more than 6,000 robots with customers located in more than 40 countries. The company has more than 250 full-time employees now, and we're selling around 2 new robots a day. So it's been a rapid rise. Since our last robot launch in 2018, the OT2, we've raised a Series C round of funding, which we're using to drive new product development efforts. So the first of the new products that we've been working on came out last year. So a heater shaker module and a second generation thermocycler module. Both of these modules are forward compatible. So we built them with the Flex in mind, and they also work with the OT2. So, I guess, I'm burying the lead here, but the big reason you're all here is last month we announced our new next generation robot, the Opentrons Flex, which will start shipping to US customers in August. So we've got a big summer ahead of us. So now I'll turn things over to my colleague, Mike Todaro, to take a closer look at the Opentrons Flex.
Thanks, Mike. Hi, everybody. I'm really excited to be here today to share with you some of the really cool features of the Opentrons Flex, our newest robotic offering. So if you go to the next slide, I'll talk a little bit about the Flex in context of the overall Opentrons ecosystem. And I think first and foremost, the benefit of an Opentrons Flex is that you get the same benefits of the same software ecosystem that you currently have with the OT2. You're able to exchange modules between those platforms. So as Mike was saying, the thermocycler, newest generation, the heater shaker, our temperature module, if you already have those modules and already have an OT2, they're fully forwards compatible. You can use those same modules on both the OT2 and the Flex. And this industry-leading serviceability you're used to from Opentrons will continue. So you can really leverage all the experience and the things that we've done in the past with the OT2 with the Opentrons Flex. I think where the Opentrons Flex represents an evolutionary advancements in our robotics offering really comes from the fact that we focused on supporting higher throughputs and more complex workflows. The footprint of the Flex is larger than the OT2. So the OT2 can fit in a biological safety cabinet, for example, but it's really ideal for things like sample reformatting, reagent prep, routine workflows, where the Flex is able to support much larger, higher throughput types of protocols. It comes with a modular pipetting head system with a series of broad volume ranges. We'll get into that on the coming slides. And it's coming with a 96-channel pipette. So you have higher volume, higher formats, higher throughput support with the Opentrons Flex. So if we go to the next slide, I'm going to start talking about some of the new features individually, some of the things that we're really excited about to bring to market with the Flex. And first and foremost amongst those is the gripper. So in order to extend the walkaway time for scientists, the Opentrons Flex comes with a gripper, which is able to move plates and tip racks across the deck on and off Opentrons modules, really increasing the walkaway time for scientists. You no longer have to manually take plates and move them from one module to another or off deck and on deck. Now we have this gripper that allows you to do that automatically. Alongside the gripper, if we go to the next slide, I mentioned before, we have 3 ranges of pipettes with the Flex. So we have our single channel pipettes, our 8-channel pipette, and a 96-channel pipette. The nice thing about the system is, just like many other things on the deck, the pipetting system itself is modular as well. And so you're able to configure the gantry with 1 or 2 single or 8-channel pipettes, or a single 96-channel pipette. So depending on your workflow, depending on what you're trying to do, the pipetting itself is modular with the Flex. And looking on the next slide, we'll see these are really easily swappable. And so you can replace the pipettes and the grippers yourself. A single person, as you can see from the GIF, is able to do that activity. So as you're doing different activities, as you have different needs with this robot, it's very easy for a scientist to swap in and out gripper and pipette parts to support exactly what you need to do in your workflow. On the next slide, you'll see some of our pipette specifications. So focusing specifically on the single channel pipette, I do want to highlight a couple of key specs. We've done rigorous testing of these specs. We're very confident in our accuracy and our precision. And you can see here for the single channel pipette, we've hit some really good industry leading targets. Next slide. So with the gripper and with the pipettes, calibration is required. With the Flex, that's done automatically with a single one-touch process. So the Flex has a touchscreen, as you can see here, and we'll talk a little bit more about that on the next slide. But with the single touch of a button, you're able to automatically calibrate the position of your pipettes and your grippers. Next slide. Touchscreen for easy protocol setup. So the nice thing is you still have the ability to use a laptop and interface with the robot that way, but the Flex does have an on-device touchscreen display. You can use this to go through your guided setup. Using the dynamic deck maps makes it much easier to go through and set up your protocols using this device display. You can also send protocols to the machine using this display as well. So a nice, easy way for users to interface with the robot. Next slide. And then finally, we've talked a little bit about the modularity of the system. I do want to highlight all the different items that are available for use on the Flex. And so we have a magnetic block, we have our thermocycler, our heater shaker, our temperature module, and a waste chute for higher volume. Highlighting that the thermocycler, the newest generation of that, the heater shaker, and the temperature module, again, are compatible both with the Flex and the OT2. So if you already have one of those modules, you can use that for the Flex without having to repurchase those modules. Great. I think with that, I will hand over to Kinnery to go through some performance testing.
Thanks, Mike. Here, I really just want to highlight a couple key applications that we've tested in the lab with particular focus on workstations that we will offer with the Flex. So here, just highlighting them in specific, the workstations that we will provide not only will include the consumables and pipettes and modules required to seamlessly automate these assays, we also will have libraries available for really easy automation of these particular key applications, namely NGS library prep, nucleic acid extraction, PCR, in both plate preparation and in fully automated formats with our on-deck thermocycler, and with for protein purification as well. All of these right now, up to 96 samples, notably with PCR preparation, you can exceed that throughput. So diving into some of the data a bit more specifically, here is some data that we generated with E. coli genomic DNA samples, constructing libraries with some standard enzymatic fragmentation methods here. So if you bring your attention to the tape station gel on the left, you'll see the distribution across the samples that we queried is pretty consistent. We also see that for the peak fragment size as well. So here we were targeting for a particular paired end MySeq run, our peak fragment size was within the range, and then of course, very consistent across the libraries that we did construct. But we don't stop our QC there. So actually interrogating the sequences and the reads that we are able to analyze, the mappability is also extremely high. So we're seeing that high mappability back to our E. coli reference, which is really exciting. And then additionally, the other kind of error rate, duplicate rates that we would be inspecting, they're incredibly low when we construct libraries on the Flex. So yeah, moving to a more qualitative, thanks Mike, application here, the protein immunoprecipitation. So as I mentioned, a lot more qualitative, but we still take it out to some image processing to understand this. So here we're pulling down GAP-DH, which is a really common target here from some Hep2 lysates we had propagated in the lab. And our CV is really consistent when we analyze that really clean gel that we're seeing here on the band on the gel, rather, below 8%, which is really, really exciting. And in addition to the consistency that we're seeing from the samples within a run, we are able to really target some high efficiency for this particular assay. So for a plate of 96 samples, we can process this in under 2 hours, which is really exciting for such a core proteomic experiment. As we move to extraction here, I wanted to bring your attention to the deck layout a bit here so I could highlight a couple really interesting things about how we're setting up nucleic acid extraction on the Flex. So you have plenty of room for your reservoirs for reagents, the magnetic block, the tip racks, everything you'll need for extraction, in addition to the temperature module. So we can be actively cooling our samples as they're eluted, so keeping them really stable. In particular for RNA extraction, that becomes pretty critical. So we're able to do that and keep the walkaway time as ideal as possible. And then, of course, the heater shaker. So we have incorporated the heater shaker in many of these workflows, and we're seeing that it's really effective at resuspending those large volume bead solutions. So we're getting really high yield and really clean elution here. I highlighted a little bit of data that we generated from the lab on the left. I'm showing a 48 sample format of this particular protocol. So we use some multi-channels to generate this data. And what we're seeing is this is some genomic DNA from HeLa cells that we had going in the lab, and the integrity and the purity of these DNA samples is extremely high. It's on target for what you would expect. We're seeing really high uniformity, so we're seeing really, really low CVs when we analyze across. This is of 48 samples that we queried for this particular experiment. So the DNA that you're able to extract in this particular instance and very consistently in the lab is ready for your downstream applications as soon as it's done being processed on the Flex. So we're really excited about the performance in particular of these key applications, but for many applications that are supported by the Opentrons Flex. So with that, I believe we'll first want to thank you all for registering, and thank you so much for your time here and attention. We do want to encourage you to fill out the Q&A box for any questions that you may have about the applications, about the hardware and software features in the Opentrons ecosystem here today. So feel free to take advantage of that, and we'll do our best to answer your questions.
Alrighty, and I do see that there are many questions coming in. We're trying to answer as many of those as we can in real time using the chat feature, but there are a few that I think it makes sense to answer live. So I will go through those. I'll serve them out to the team. If we don't have a good answer for you now, we will make sure to note these down and follow up with you separately after the webinar. And so the first question I want to queue up here is for Kinnery. And following up on what you were just presenting, Albert asks, could you please elaborate the automated calibration process? For example, how long does it take to finish one calibration? Do you need to do this positioning before every run? OT2 needs labware positioning manual before every run. Does Flex fix this issue?
Yeah, I will definitely take that, Mike. And I'll just speak to our experience in the lab because we're really the first internal customers in that manner. So we have not had a ton of issues at all. Calibrating is really easy. It's a few minutes. The automated calibration is really exciting. So extracting kind of some of the pain points of extracting and finding manual placements on the deck visually. So it should take a matter of minutes, and you should not have to be doing it every time you run a protocol.
Thank you very much. And I think one more for you, again, following up on what was just presented. For the applications where these assays were done using the 96 channel head, were they done using the 96 channel head or one of the other heads?
It's a great question. So the extraction data, as I mentioned, for a 48 sample, we were using the 8 channel. So our multi-channels were doing the work there. For the protein immunoprecipitation data, we were actually using our very exciting new feature, the 96 channel pipette.
Very good. I see a couple of questions about the waste chute, so I'm going to group those together and answer them. So following up on the waste chute question, which side of the robot will this be on? The waste chute will exit out the front of the robot. So the waste chutes will require a replacement of the door so that it can exit from the robot, but it will be the front side of the robot is where the trash chute will be located. And then a second question about the waste chutes. Does the waste chute replace the trash can on the deck? It can, or they can be used in tandem. So depending on what your protocol requires, I think it's probably unlikely you'd want to use them in tandem. If you're doing a high throughput protocol, you probably want to use the waste chute, but there's no reason that you couldn't use both of them simultaneously. Great. Okay. Another question. Will it be possible to program Flex with Python? Mike Cardarelli, why don't you take that one?
Yep, Python protocols, will work on the Flex. If you're updating from an OT2 one to a Python one, or to a Flex one, you'll have to make a few small changes, like things like the pipettes are different, so you have to specify those. But overall, it's the same. There's new things in the Python protocol API, like the gripper commands, but the bulk of it is the same that you use on the OT2. There'll also be protocol designer is compatible with the Flex at launch. We do have, I can kind of promote this a bit. There is a software specific Flex webinar next month that we encourage you to sign up for.
Great, thanks.
Other similar questions? Yeah.
I think let's keep going through here. A question, is liquid sensing available? You want to take that one as well, Mike?
Yeah, all of the new pipettes have pressure sensors to enable liquid sensing and liquid level detection. This is not something that is going to be ready for August when the first units ship, but the hardware is there. So it's planned for a post-launch software release and where this feature will be enabled. But it's been in the plans for this robot from the start.
Very good. Let's go to the next question. A question about DNA extraction on deck. So typically using a centrifuge. Kinnery, do you want to answer how you're doing on deck DNA extraction?
Yeah, definitely. So for all the applications that I was highlighting, we're in magnetic bead format. So we don't do any centrifugation on the deck. If there are steps that, you have a particular sample that you prefer or are inclined to centrifuge for upstream steps, you're fine to do that. But for all of these, we're actually able to fully automate. We've done quite a few tissue types without much prep and without centrifugation.
Great. Okay. So next question. Does the gripper only work with 96 well plates? And Mike, would you like to answer that?
No, the gripper will work with other labware. We're testing it with other kinds of labware, including tip rack boxes. So I think with the trash chute, you're going to have a lot of flexibility and the option to remove all kinds of labware from the deck to give yourself more space as you work.
Okay. There's so many questions here. I'm trying to sort and group them in real time, so bear with me. Next question. We have custom labware definitions that use a calibration point. Does that require calibration each time, or is there a way to define the labware so it is included in the automated calibration? I'll start that one with Mike, but feel free to kick that to somebody else.
I don't know. I see Kinnery nodding. What? I'm not totally sure what they mean by that.
You want to jump in, Kinnery, or maybe we can take this one?
Yeah, I think we wouldn't want to misspeak. I think that's a great option for more discussion. We can email follow-up afterwards.
Great. I will notate that for follow-up afterwards. Okay. Maybe a question for Fran, actually, who's in the background. Are you planning to have a trade-in program for upgrading from OT2 to the Flex?
Thanks, Mike. So it is not active at the moment. We have discussed it. One of the reasons why we are not necessarily focusing on that is that we do think that a lot of people will want to use both. So, you might get a Flex and then transition your OT2 to do a sample prep or a tube to plate type part of the process. So we see a lot of application for having both systems in the lab. But again, we can follow up one-to-one with that specific person to answer more, talk through options.
Great. And then I see a related question that I am happy to answer. Will you still provide support and sell parts for the older Opentrons robots? And the answer to that is yes, because we do see these as complementary robots and not the Flex being a direct replacement for the OT2. If you have an OT2, OT2s will continue to be supported, as will all of their peripherals. Okay, next question. Are Flex pipettes compatible with universal fit tips as with the OT2? I will farm that over to Mike.
No, there's different tips for the Flex, and they're, yeah, I mean, I think these are automation tips versus manual pipette tips that the OT2 uses. 3 sizes, like 50, 200, and 1,000. We're getting good results in testing, and yeah, so they're different. You can't use the OT2 tips on the Flex.
Okay, question about the number of deck slots. The answer to that is 12. There are 12 deck slots on the OT Flex. Okay, let's see, another question. I see 4 or 5 questions about pricing. So not an unexpected question. I believe we actually have a slide that will walk through this, and I will hand over to Mike to present it.
Yeah, you can see here the workstation ranges and the individual prices for the robot pipettes and the gripper, I guess a la carte pricing. Yeah, I'm not sure if there's more specific questions here, but yeah, this will be in the export when we send these slides out.
Great. Any additional context you want to add to that, Fran?
Maybe just so, as if you have an OT2, you know you can buy a la carte options, and it's all fully modular. And we will have workstation offerings, which are bundled options, and those are about a 12 to 14 or 15% discount if you bought all of the components in that workstation individually. So the bundles are pre-configured to work kind of to your specific application, and they do offer a savings based on all of the different hardware and consumables that you get in them.
Very good. Okay, moving on. There are a couple questions about the maximum payload of the gripper, and the answer for that is about 2 kilograms. About 2 kilograms for the maximum payload for the gripper. Okay, question about the 96 channel. Can you use the 96 channel to pipette into 384 well plates? I'll start with you, Mike.
I think you will be able to. I haven't seen the testing results on this, but I think that's the plan. Does that sound right to you, Henry?
Yeah, I think it's a bit out at launch. So by the time many of our customers will be receiving this, we encourage you to use this in a 96 format.
Okay, a couple of follow-ups on the trash bin. Sounds like maybe this was not clear when I answered it before. So is the trash bin still an option, or will we need to have a trash chute set up? You do not need to have a trash chute set up. The trash bin is still an option. You can use either or both simultaneously. So the trash bin is still an option on the OT Flex. Okay, and then another follow-up on the trash chute. Does it allow full use of the 12 primary deck slots, or does it obstruct one? It does take up 1 deck slot. And so it's just like a module in terms of how you can think about it interacting with the robot. It will take up a deck slot, and then the robot will acknowledge that that deck slot has been taken up by a trash chute. It's able to be integrated into protocols. Magnetic block, is it only for Flex, not OT2? So we do have older generation magnetic modules that are available on the OT2. This specific magnetic block is designed for Flex only. So that is the one module that is not compatible between the OT2 and the Flex. Okay, a question about a camera. Will the camera inside be easy to use or easier to use than the one on the OT2? Mike, do you want to address the use of the camera?
Yeah, there is a camera. It's much better quality than the OT2. This is something that we really want to leverage for future functionality post-launch. I think early days, you'll be able to control it through the API, but we aren't really using its full capabilities yet, but it's similar to the pressure sensors on the pipettes. It's there for when the future software releases can really help it become more useful. So yeah, I think it's something that we're planning on being a big part of the Flex story, but I think we're gonna walk before we run there.
Okay, great. I'm grouping together another couple of questions about when the Flex ships. And so 3-part question for you, Fran. When is it shipped to the US? When is it shipped to Canada? And when is it shipped to the EU? Maybe you want to round that off and just say, when is it going to ship worldwide?
Sure. Yeah. So the first US will start in August. So US customers that order now should be receiving robots in Q3, Q4. And then we will begin shipping internationally beginning of 2024. And that applies to Canada and Europe.
Perfect. Thank you very much. Okay, another question. This one might be one we want to take offline, but I'll ask it just in case. And for Mike, what is the maximum height of a piece of custom labware?
Yeah, we'll have to follow up. I don't know off the top of my head.
Okay, great. Questions about if the Flex can be connected to each other or to OT2s in order to expand deck space. And maybe a question for you again, Mike.
Yeah, I mean, you can't connect the decks together. The gripper wouldn't be able to reach onto another deck. I think we've already heard some interest from people who want to create workflows with an OT2 and a Flex. But you would have to create an integration to pass labware between the two robots, which is, capable with our HTTP API, but it's not going to work off the shelf. So yeah, I think we're excited to see how people combine our two robots out in the wild. We've already heard some cool ideas. So I think we'll be publishing case studies and things like that as we hear how our community is leveraging these tools together.
Great, thanks, Mike. A couple of questions that I'm going to pick up here. Question about if HEPA filtration will be available. The answer to that is yes, but not at launch in August. So this is a feature that's under development. It should come shortly after the Flexes begin shipping. It is on our roadmap. It is in active development right now. It is not available at launch. And then, can you install the gripper into an existing OT2? The answer to that is no. The gripper is only a Flex feature. Okay, another question that may require follow-up, and I'm going to direct this one towards Kinnery. Kinnery, do you know what the CV for the 96 channel head is?
Yeah, right now those specs are really close to the specs that we're laying out here for the single channel pipette. So you'll have that as a reference in the documentation as a follow-up. And Mike is kind enough to slide back to you. So yeah, you can definitely use these as references for considering what our low volume is going to look like for the 96 channel pipette. I will say, keeping in mind that that is closer to that Opentrons Flex 5 to 1000 microliter range.
Very good. And then another question for you, Kinnery. Will buying the NGS capable Flex take care of NAE and PCR workstations?
Yeah, this is a great question. So if you're interested in flexibility, obviously we're really leaning into the flexibility of this platform. If you have the components for the NGS workstation, you would definitely have a lot of the components that you would need if you would be doing PCR. So you would have a on-deck thermocycler, you would have a magnetic block if you needed to do extraction. So it's a really flexible platform.
Great. A question about pipette swapping that I'm going to direct to you, Mike, and maybe it's worth toggling back to the pipette swapping slide. So the question is, does pipette swapping require any cable disconnection or reconnection as the OT2, or is it now more straightforward? And then is it possible to swap pipettes during runs for more complex protocols that would require going from one different format of pipette to another?
Yeah, I mean, it's much easier to attach. I don't know if you have more you want to add there, Mike, but I think the swapping during protocols, I don't think we would recommend that. I think, you know, you can leverage a single NNA channel. We are going to work on, or we are working on partial tip pickup from the 96. So that will probably be the recommended way to do this. But I could see some major issues if you were swapping pipettes and then needing to calibrate in the midst of a protocol.
Yeah, that's the same answer I would have given. And I have some experience with doing the swapping of pipettes, so I can speak to my experience with it. And then maybe Kinnery wants to join in as well, because I know that the science team has been using these extensively. So the disconnect and reconnection process is much more straightforward. The 1 in the 8 channel, it's possible to do with one person very easily. It's a screwdriver and then kind of angle and click activity to disconnect and reconnect those pipettes. The 96 channel head is a little bit heavier. Someone like me who's a little bit bigger is able to do it, but we would probably recommend that if you are going to swap the 96 channel, you make that a 2-person operation. But the same activity is required to change any pipette. It's a screwdriver, an angle, and a click. Anything you want to add to that, Kenner?
Yeah, I'd agree. Thank you for being inclusive, Mike. I'm a great deal shorter than you. So yeah, it's definitely helpful. We're alleviating that cable concern that the person that wrote this question was mentioning. So that is definitely alleviated with attaching pipettes on the Flex.
Great. Another question that's come in about the payload of the gripper. So just to reiterate, that is a 2 kilogram, approximately 2 kilogram max payload. Okay, next question. Will you provide today's presentation? Yes, the presentation will be provided after the webinar within 48 hours. Okay, next question. I think that I'm going to direct this one to Mike, and this is, does the Flex touchscreen interface allow any flexibility with adjusting Python protocols? So for example, could you adjust the number of rows to dispense liquid using the Flex interface?
Yeah, this is something that we've laid the groundwork for already and is going to be a post-August feature, but being able to adjust runtime parameters in protocols from the touchscreen. So we know this is something that Opentrons users have been asking for a while. So you'll have the option to change things like sample count or volumes from the Opentrons desktop app when you're at runtime, or from the on-device display. So we've already been making some changes underneath the hood, and that's something that obviously requires a lot of testing. So something that we're excited as a post-launch feature that we'll be rolling out through a software update.
And then another question, which I'm going to point towards you, Mike, and you may want to defer this to the software webinar that's upcoming. But in terms of developing scripts using the API, are those scripts simulated in the same way as they are on the OT2?
Yeah, there's a lot of the same shared code that you'll be familiar with if you're an OT2 user. So yeah, a lot of this is going to be very similar, but we'll have more info in the software webinar. So definitely attend that one if you have more specific software questions. It's just a lot to cover. Obviously, we're kind of focusing more on the hardware of the Flex today, but there's all kinds of future software work that's coming down the pipeline. So if you're interested in the software, like definitely recommend you joining July's webinar about that.
Great. A couple of questions I'm going to group together and direct towards Fran. And Fran, you may want to follow up with these offline. These are all questions around what the installation, setup, and preventative maintenance process is for the Flex. So once it's shipped, what does the installation and setup process look like? And then what does the maintenance schedule look like? And what sort of longevity should people expect to get out of this system?
All great questions. I might need you to remind me of some of them if I come back. Let's start at the beginning though. So we do offer a range of a la carte and contract services. So we do provide on-site installation in the US. We will have international options as well for installation. And we do on-site and remote protocol development. And we also have preventative and premium maintenance options via service contracts, which it's probably better to discuss your specific needs in a one-to-one call, but we do have all of the kind of service offerings that you would expect, including like PM and online support and site visits and so on. So installation is a one-day process. So we would come on site and install the robot for you on site. If you couple that with, if you wanted to have a completely sort of intense sort of hand-holding solution, then we would also could come on site and do protocol development as well to get you completely up and running and ready to roll. It depends a little bit on the complexity of your protocol as to how long would need to be on site if you wanted protocol development. Of course, those of you who know and love the OT2 also know that you can create your own protocols. So you could do it that way as well. And we also have remote protocol development. So it doesn't have to be on site if you wanted to do that. So I think the easiest thing to say is that we have a lot of very flexible service options for service and maintenance and protocol development, as well as our on-call support team who are available through chat and email at all times. Did I miss anything, Mike?
I think that covers it off. Thank you. Okay, another question, another couple of related questions actually that I'll send your way, Mike. And this is about extensibility of the system. And so there are questions about if Opentrons is considering the ability to stack plates on deck, as well as something like a plate shuttle or a plate hotel off deck. Anything you want to say about plans for that?
I mean, it's a good question. I think obviously we have a gripper now and we want to go as high throughput as we can. So these are things that we're looking into. I think it's too soon to promise anything. Some of the other stuff that I've said is like post-launch, it's because it's something that's fairly far along in development, like runtime parameters. But I think people are going to be able to hack with the gripper. They will be able to do their own stacking, but as far as making it super user friendly and having it be very polished in the software, that's not something that we're working on right now. So will you be able to stack plates? Like probably. Is it going to be the most polished experience at launch? No, it's just kind of behind some other priorities in the launch list here. But we know people want to do this, and we know they want to stack tip boxes too. And the gripper and the waste chute really changed the game for us. You don't have the limitations throughput wise that you did with the OT2. So we're heading in this direction, like a plate shuttle direction and a stacking direction, but not going to be there at launch.
Thanks, Mike. Another question for you about the touchscreen. Does the touchscreen act like a computer? For example, does it have the ability to install other apps or have browser access? Or is it only intended to run the Opentrons app?
It's only intended to run the Opentrons app. But it is I'm not sure the right term, but it is like a Linux device, and we are open source. So if you're very technical, I think you can have fun with that. But we haven't really built any fixtures to make it easier to hack the screen. I think the intended behavior is to use the touchscreen software. But kind of like stacking plates with the gripper, like we'll see what our community does, because they kind of amaze us every day. So I think we'll see some of the creativity of our community leveraging the screen.
Thanks, Mike. There's a question here about if you were able to take the Flex on the road in a mobile lab setup, say in a van or a shipping container. I'm going to interpret this as a dimensional question. If you would like the person who asked that question to follow up with clarification, that would be great. But Mike, if you want to toggle to a slide that shows a user standing next to the Flex, we can give a rough idea of the dimensions of the system. So it's bigger than the OT2. It is a 2-person lift, I would say. We've done several unboxings of these, and it does take 2 people to get them out of the box. So if you are able to get 2 people to maneuver one of these into a mobile lab setting, I don't think there's any reason why dimensionally you couldn't do that. I'd be really interested to understand what that setup would look like. That sounds like a really cool idea. But there's nothing that would preclude you from being able to put this into a mobile setup dimensionally. Great.
The one thing I might add is just it's maybe obvious, but like keeping the robot flat is quite important like when it's in use. So that's just something you might not want to park on a hill.
Very true. Okay, question about the 96 channel head, and maybe I'll direct this one towards Kinnary. The question is, can the 96 channel head pick up columns, rows, individual tips, or only 96 at a time?
Yeah, it will soon be able to do all of those partial tip options. Right now, we've been doing so much with the 96 channel in its full form to pick up 96 channels, but upcoming definitely we'll be able to have partial tip pickup options there for column wise, row wise, and other options.
Great. And then maybe another follow-up question. Can you elaborate on the protein purification method? 2 hours for 96 well plates sounds promising. Have you tested the capacity of how many plates can be handled in succession without reloading the deck? If yes, how does that affect the runtime?
Yeah, I think that was a triple barrel, Mike. I'll try to remember it all, but yeah, you were just on that slide, but if not, we can move forward. Thanks, Mike. So for this, we actually, I mentioned that Hep2 lysate, we're pulling down gap DH, magnetic bead based, of course. Here we actually used Dynabead protein G beads for the actual processing of the protocol here. Yeah, I think there's quite a bit. What I will add here is that we will provide the protocol that we use to generate this data on the library soon. So you'll be able to take a look at all of the steps in detail in the code base, but it's pretty straightforward. It's a bind, wash, and elute process like many other bead-based protocols. And here we're just highlighting that it's pretty quick to get through that first plate. We have done some initial testing of more than one plate, but right now we've been focused on getting that 96 process to be as efficient as possible.
Okay, thanks. A question about swappability of the pipette heads. So can you have 96 head and swappable 8 and single channel heads, or is the second head choice locked? So you can have either a 96 channel head or a combination of 8 and single channel heads. You can't have both the 96 ends and 8 and a single channel. Okay, couple more questions here. A question about controllability of the system. So I'll point this one to you, Mike, but again, we can take it offline if required. The question is, will a user be able to have fine control over gantry movement speeds and pipette speeds?
I need to look into the details on this. Yeah, I don't want to overpromise here. There is new motion control on this robot compared to the OT2, and new kind of homing mechanism, but yeah, I don't want to overpromise here. I think we can follow up.
Okay. Let's see. I think we've answered this one. We've answered the question about the pricing, although some people may have joined late. So maybe, do you want to page back over to the pricing and talk through that again, Fran?
Sure. Is there a specific question, or just sort of summarize again?
General summarizing.
Okay. So just like the OT2, you can buy the components in a sort of modular fashion. So the base robot is $15,000. And then the pipettes obviously are different prices depending on the number of channels, but range from $2,500 to $13,000 for the 96 channel, and then the gripper is $7,500. All of our module pricing is on the website as well, but those range from about $4,000 to 10 or 11 for the thermocycler, I think. And then you can also buy the Flex as part of a bundled workstation, so for common applications. So an NGS workstation will include all of the pipettes, modules, and a bundle of labware to get you started that you need for doing NGS library prep. Similarly for NAE, that's nucleic acid extraction, everything you need to do that. PCR workstation, you can actually get it with or without the thermocycler. And protein purification is, again, a magnetic bead-based protein purification, so it comes with a mag block. And so those workstation bundles are everything you need, as I mentioned, and they come at approximately a 12, 13, or 14% discount relative to buying all the components a la carte.
Great, thank you very much. Questions come in about the unboxing and setup process. Specifically, how difficult is it to unbox or set up the Flex? I think I'll point this one towards Kinnery. I know your team's done some of this activity already. Do you want to speak towards your experiences of unboxing?
Yeah, I think it's pretty straightforward. Kind of similar to what you were saying, Mike. It is going to be a 2-person lift to get this onto your standard bench. So that's probably one thing to highlight, but general kind of setup and unboxing can be pretty straightforward. That said, we do have install and service offerings, as Fran was mentioning. So there are a lot of options for setup for customers.
Great. Here's kind of a fun question for you, Mike. Is it possible to eject 96 tips back into the tip box?
Yeah, you can eject back into tip boxes if you use the Python protocol API.
Great. And then another question for you, Mike, although this one may be better left towards the software webinar. And the question is, has the GUI protocol designer been updated? And then there's some follow-up questions about things that would be nice features, but maybe let's just stay on the question of how has the GUI protocol designer been updated?
Yeah, there's some light changes to make the PD, sorry, we call it PD, Flex compatible, but there's future plans post-launch to have a more full redesign. But in the near term, we're just getting the Flex working with the existing protocol designer. And certainly if you're going to do more complex workflows, we still recommend Python for that. But protocol designer has big fans and users. So you know, we wanted to make sure that was ready at launch of the Flex.
Great, thank you. I know we are approaching time here, and there's a handful of questions that we haven't been able to get to, but they have been logged. So we will make sure to follow up with these individually after the webinar. I think the last thing to talk about, if you go to the final slide in the presentation, other than saying thank you all for joining, it's been a blast getting all of these questions and interacting with the community. I really enjoy doing these webinars. It's a lot of fun for me to see the engagements and how many people are so interested in our new robotics offering coming out. We've alluded to this a couple of times, and I know there's been a few questions about this in the Q&A. What is this next mysterious Flex software webinar we've been speaking about the whole time? Well, here it is. On July 19th, we'll be going into a deep dive into the Flex software features. There's a bunch of new, really cool software features we're excited to share with you. Today's webinar was primarily an introduction to the robot itself, specifically the hardware features, all of those great software questions that you've asked. If you want to get into more detail about them, this would be a great opportunity. So July 19th, scan the QR code, sign up for that webinar. We'll be really excited to have you. And with that, thank you all so much for joining. It's been a blast, and hope you all continue to enjoy the Opentrons experience.
Great questions. Thanks.